AI versus machine learning versus deep learning. These are the terms which have confused a lot of people, and if you too are one among them, let me resolve it for you. Well, artificial intelligence is a broader umbrella, under which machine learning and deep learning come. You can also see in the diagram that even deep learning is a subset of machine learning, so you can say that all three of them, the AI, the machine learning and deep learning, are just the subset of each other. So let's move on and understand how exactly they differ from each other. So let's start with artificial intelligence. The term artificial intelligence was first coined in the year 1956. The concept is pretty old, but it has gained its popularity recently. But why? Well, the reason is earlier we had very small amount of data. The data we had was not enough to predict the accurate result, but now there's a tremendous increase in the amount of data. Statistics suggest that by 2020 the accumulated volume of data will increase from 4.4 zettabytes to roughly around 44 zettabytes, or 44 trillion GBs of data. Along with such enormous amount of data, now we have more advanced algorithm and high-end computing power and storage that can deal with such large amount of data. As a result, it is expected that 70% of enterprise will implement AI over the next 12 months, which is up from 40% in 2016 and 51% in 2017. Just for your understanding, what does AI? Well, it's nothing but a technique that enables the machine to act like humans by replicating the behavior and nature. With AI, it is possible for machine to learn from the experience. The machines are just the responses based on new input, thereby performing human-like tasks. Artificial intelligence can be trained to accomplish specific tasks by processing large amount of data and recognizing pattern in them. You can consider that building an artificial intelligence is like building a church. The first church took generations to finish, so most of the workers were working in it never saw the final outcome. Those working on it took pride in their craft, building bricks and chiseling stone that was going to be placed into the great structure. So as AI researchers, we should think of ourselves as humble brick makers whose job is to study how to build components. Example parts is planners or learning algorithm, or accept anything that someday someone and somewhere will integrate into the intelligent system. Some of the examples of artificial intelligence from our day-to-day life: our Apple series, just playing computer, Tesla self-driving car, and many more. These examples are based on deep learning and natural language processing. Well, this was about what is AI and how it gains its hype. So moving on ahead, let's discuss about machine learning and see what it is and what pros of it introduced. Well, machine learning came into existence in the late 80s and the early 90s, but what were the issues with the people which made the machine learning come into existence? Let us discuss them one by one. In the field of statistics, the problem was how to efficiently train large complex model. In the field of computer science and artificial intelligence, the problem was how to train more robust version of AI system, while in the case of neuroscience, problem faced by the researchers was how to design operation model of the brain. So these are some of the issues which had the largest influence and led to the existence of the machine learning. Now this machine learning shifted its focus from the symbolic approaches it had inherited from the AI and moved towards the methods and model it had borrowed from statistics and probability theory. So let's proceed and see what exactly is machine learning. Well, machine learning is a subset of AI, which the computer to act and make data-driven decisions to carry out a certain task. These programs or algorithms are designed in a way that they can learn and improve over time when exposed to new data. Let's see an example of machine learning. Let's say you want to create a system which tells the expected weight of a person based on its size. The first thing you do is you collect the data. Let's see, there is how your data looks like now. Each point on the graph represent one data point. To start with, we can draw a simple line to predict the weight based on the height. For example, a simple line W equal x minus 100, where W is weighting kgs and edges height and centimeter. This line can help us to make the prediction. Our main goal is to reduce the difference between the estimated value and the actual value. So in order to achieve it, we try to draw a straight line that fits through all these different points and minimize the error. So our main goal is to minimize the error and make them as small as possible, decreasing the error or the difference between in the actual value and estimated value increases the performance of the model further. On the more data points we collect, the better our model will become. We can also improve our model by adding more variables and creating different production lines for them once the line is created. So from the next time if we feed a new data, for example height of a person, to the model, it would easily predict the data for you and it will tell you what his predicted weight could be. I hope you got a clear understanding of machine learning. So moving on ahead, let's learn about deep learning. Now what is deep learning? You can consider deep learning model as a rocket engine and its fuel is its huge amount of data that we feed to these algorithms. The concept of deep learning is not new, but recently its hype has increased and deep learning is getting more attention. This field is a particular kind of machine learning that is inspired by the functionality of our brain cells called neurons, which led to the concept of artificial neural network. It simply takes the data connection between all the artificial neurons and adjusts them according to the data pattern. More neurons are added at the size of the data is large. It automatically features learning at multiple levels of abstraction, thereby allowing a system to learn complex function mapping without depending on any specific algorithm. You know what? No one actually knows what happens inside a neural network and why it works so well, so currently you can call it as a black box. Let us discuss some of the examples of deep learning and understand it in a better way. Let me start with a simple example and explain you how things happen at a conceptual level. Let us try and understand how you recognize a square from other shapes. The first thing you do is you check whether there are 4 lines associated with a figure. Thanks for watching. Please remember to like this video and subscribe to this channel.